Hey everyone, welcome to The Explainer. I know you've got a massive exam coming up, and you really need to lock down the fundamentals of machine learning and natural language processing. Well, take a deep breath because you are in exactly the right place. We're going to take all those dense lecture notes and transform them into a crystal clear, high-yield study guide so you can walk into that test with absolute confidence. Let's get right into it.
Okay, so here's your roadmap for this session. We'll cover rules versus data, the machine learning pipeline, types of machine learning, NLP and probabilistic models, and we'll wrap it up with challenges and AI toolkits. All right, kicking things off with Section 1, Basics, Rules versus Data. To pass this exam, you absolutely have to understand how machine learning completely flips traditional computer programming on its head. I mean, it literally reverses the process. In traditional programming, developers take an input, they write an explicit program, basically step-by-step instructions, and the computer spits out an output. But ML, that is a total paradigm shift. You feed the computer the data and the output, the answers, and the computer itself finds the patterns to create the rules.
And when you look at this, you're seeing that core shift in action. You're feeding both the input data and your desired output into the machine. The result that pops out on the other side, that's what we call the model. Think of the model as the ultimate rulebook that the computer just authored for itself through the learning process. And, the more high-quality data you provide, the better that rulebook becomes.
Let's do a quick active recall check, because examiners love applied questions. Think about trying to manually write a traditional rule to catch scam direct messages. You might say, okay, block any message with the word urgent. But wait, what if your boss texts you urgent? Your rule totally fails. This is exactly why we need the machine learning approach. Instead of writing brittle manual rules, we just give the computer thousands of examples of scams and let it uncover the hidden patterns all on its own. Now, this really highlights the gap in what we call knowledge and learning. We humans instantly see a furry orange cat, but the computer, it only sees a giant grid of numerical values representing pixel intensities. Bridging that massive gap between human perception and mathematical grids is the main hurdle ML has to jump. Since computers basically just see a sea of numbers, we have to help them focus on what actually matters. And that brings us to the true art of machine learning, choosing the right features. It's like extracting the distinct edges or the specific color map of a swan sitting in the water. This is called feature engineering, and you definitely want to start this in your notes. Why? Because it heavily influences whether your model succeeds or completely falls apart. Moving right along to Section 2, the machine learning pipeline. So, this is the actual step-by-step process of creating a functional AI model in the real world. You need to memorize this exact sequence for the test. First, data collection. Second, pre-processing, cleaning that data up. Third, algorithm selection. Fourth, training the model. And finally, evaluation. And here is the absolute kicker. If your evaluation shows the accuracy is too low, you have to loop all the way back to the start. It's a continuous, iterative process. Let's apply that pipeline right now. Say you're building a model to predict if a student will pass an exam. What features or data points do you feed into step 1? Study hours, past grades, attendance? For sure, those are huge. But what about their shoe size or their favorite color? Completely irrelevant, right? Remember, features are the senses of the AI. If you feed it garbage senses, you are going to get garbage predictions. All right, Section 3, Types of Machine Learning. Now that we've got our data features, distinguishing between these 3 major learning buckets is a guaranteed high-yield exam topic. We've got supervised learning, unsupervised learning, and reinforcement learning. Try to get a really good mental picture of these categories because they perfectly hint at how the algorithms actually operate under the hood. Okay, get your pens ready for these definitions. Number 1, supervised learning. This is when the machine learns from labeled data, meaning you give it the input and the exact correct answer to train on. Number 2, unsupervised learning. This is where the machine has to find hidden patterns in data without any labels at all. And number 3, reinforcement learning. This is where the machine learns strictly through trial and error, basically earning digital rewards for correct actions.
Next up, Section 4, NLP and probabilistic models. So what happens when we apply all these ML concepts to human communication? Well, the core problem NLP has to solve is that human language is incredibly messy and ambiguous. Words have multiple meanings depending on the context. So AI simply cannot use rigid rules. Instead, it relies on probabilistic models to guess the most likely meaning. In NLP, AI is dealing entirely with degrees of belief rather than absolute hard facts. To even begin wrangling those degrees of belief, NLP has to turn unstructured text into structured data. And the very first step to do that? Tokenization. For the exam, just remember that tokenization is simply breaking paragraphs or sentences down into individual words or tokens so the machine can actually process them mathematically. Once everything is tokenized, we can run some really cool basic NLP tasks. A super vital one is sentiment analysis. This is where the model determines the emotional tone behind a piece of text. Like, is this customer review positive, negative, or totally neutral? It's all based on calculating the probability of certain word patterns. Another core task is named entity recognition, or NER. Basically, think of this as the AI acting like a super fast highlighter. It automatically scans through raw text and yanks out specific, important entities, like people's names, geographic locations, dates, and organizations. So how is all this used out in the wild? Well, because human communication requires intent, NLP helps machines mimic that intent. For instance, machine translation doesn't just blindly swap words, it uses probabilistic alignment, mapping patterns of words to convert one language to another while preserving the context. And chatbots use those exact same complex probability calculations to select the absolute best, most natural-sounding response to whatever you typed. And finally, Section 5, Challenges and AI Toolkits. To wrap up our study session, we have to look at the limitations of AI. An examiner will definitely 100% test you on these 3 core challenges. First, bias and fairness. Since models learn from historical data, biased data leads directly to unfair, discriminatory decisions. Second, privacy risks. Training on massive data sets often involves highly sensitive personal info that demands strict protection. And third, lack of explainability. Some complex models are basically black boxes that are incredibly hard to interpret, which really hurts human trust and accountability. Take a quick screenshot of this slide for your notes before test day. These are the practical AI toolkits you need to know. Gensim is a highly optimized library specifically for topic modeling and document indexing. The Google Cloud Natural Language API gives you highly accurate pre-trained models for sentiment and syntax analysis. And Stanford Core NLP is your go-to robust toolkit for deep linguistic analysis like part-of-speech tagging. All right, let's tie this whole shebang together before you head off to study. Machine learning fundamentally equals data plus patterns resulting in a model. Remember, data quality is the single most critical factor in AI success. So, as you walk into your exam and eventually out into your career, ask yourself, how are you going to engineer the perfect features? How will you extract the right senses from all the noise to build something truly incredible, fair, and accurate? Study hard, get some sleep, and good luck on the test. You are absolutely going to crush it.